So our goal in this section is to, again, review what a radian looks like. We're going to sketch angles in radian measure. We are going to talk about converting back and forth between the two and use that information to sketch tonight. And then tomorrow's practice some angles, so you'll be sketching a little bit tonight. All right, so this is where I make it real. We actually know this definition for the measure of an angle already, I think. We talked about how in this class an angle is a lot like a spinner. So the measure of an angle is actually determined by the amount of rotation from our initial side to our terminal side. And we have two units of measure we talked about. We've done pretty thoroughly now our degree measure. And today we're going to work on radian measure. Do you want me to just take the lid? I'll just take the lid off. Here. Thanks. All right. So yesterday we did an activity that was designed to help you sort of give a little bit of spatial recognition to what a radian looks like. So I'm going to actually work this definition and the example box next to it. Sort of simultaneously. What 1 radian is, it's a measure of a central angle, and our angles are always what we refer to as theta. So I'm going to start drawing an angle in here. My angle is going to be in standard position, which to review means that the initial side rests on the positive x-axis. And essentially what I've formed right here is a radius of my circle, right? We call it r. Again, notice that radian and radius sound strikingly familiar or similar. And what ends up happening is that I take this radius, and yesterday this was our piece of string. We took that piece of string and we wrapped it around the circle, and that was our string, so that our radius was now kind of just wrapped around a chunk of the circumference. It went around that perimeter just like that. You remember doing this? You can nod. Remember cutting the string to be the length of the radius and then wrapping it around? Okay. When we did that one time, we actually did make an angle. We could call that angle theta if we want to. That angle measure right there is now what we call 1 radian. And it happened because our radius was actually the same as our variable for arc length. And arc length is s in trig. So just to review, 1 radian is equal to the measure of a central angle theta that intercepts an arc s, and that arc length is the same as the radius, which was r. So that was 1 radian there. 2 radians actually kicks into quadrant 2. 57 more degrees. You might remember 3 radians from the activity yesterday was right there. Such that this guy right here, this 180 line, was 3.14 radians. In other words, 180 degrees is pi. And that goes directly back to our warm-up. You are multiplying by pi over 180, because pi divided by 180 is essentially 1. They're identical in measure. 3.14, or pi radians, was the same as our 180 degree line. So pi and 180 are the same measure. That's why you can multiply one by the other, or by that conversion factor, and not actually change the measure of the angle. Sorry, I almost misspoke there. So that's 3.14 radians. So 4 radians kind of pops us down in here. 5 radians is like right in here. 6 radians, like right in there. So that 6.28 radians, or 2 pi radians, gets us the whole way around the circle. And this was quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So those are our whole number radians. Notice I didn't put RADS after them. Those aren't degrees. If you see, like, you know, what's an angle of measure 2, and there's no degree symbol, I'm talking 2 radians. So we get kind of 2 big ideas out of this. Again, pi is equal to 180 degrees, and 2 pi radians is actually the same as 360 degrees. Alright, so my colored pencils got all the way around, I think? Yeah, okay, thanks. Alright, so this is where you're going to want to bust those out. We're getting ready for our first quiz tomorrow. So 5 was down here in quadrant 4. We're going to try to memorize best we can. So you have a little bit of memorizing to do on top of the couple of book problems you have for tonight, okay? And we're basically going to do the same diagram we did the other day. Just this time, instead of doing 30, 45, 60, 90 the whole way around, we're going to do this in radians. So that's fun. So here's pi in your eye, kids. So I'm going to start by just using my regular pencil, my black. And we'll do those famous angle measures. So some of these we already have done. So everybody see where we're at? We're kind of at the bottom of that note sheet there. Yeah. All right. And if it helps you to reference the other page that we did with degrees, that's fine too. All right, let's do this. So again, I'm drawing angles in standard position. And if I don't rotate that angle around at all, I'm just at 0 radians. If I go the whole way around the circle, I'm at 360 degrees, or what we just said is I went 2 pi radians. Then, it gets better. I could also just go halfway around the circle, and that would be pi radians. Those are your 2 big famous ones. I always found it interesting that it's actually half the circle that's pi. If you think in a traditional sense about like cherry pie, apple pie, you think the whole circle, but in math class, pi is actually only the top half of the circle. You get gypped. All right. The next one I wanted to do, the other big ones, would be if I went 90 degrees through. So if I just go that far, that's where 90 degrees was the other day. Essentially, I've traveled halfway to pi. So essentially what I did is I did halfway to pi. But we don't actually write that like that. We would simplify that a little bit. If you multiplied pi by 1/2, remember, anything could be rewritten as a fraction. And when we multiply fractions, you multiply straight across. So I would have 1 times pi over 2 times 1. Half of pi is the same as we say pi over 2. So I'm going to actually rewrite that, clean that up a little bit. I'm going to write that as pi over 2. So I went halfway to pi. What I got out of that was pi over 2. So that 90 degrees is pi over 2, which makes sense because 90 is half of 180. Likewise, down here, so I have 1 pi over 2. This guy here is like 2 pi over 2, but 2 over 2 is just 1, so we like never write that there. We are now on the 270 line, and I'm at the bottom. Let me move it here. So at the bottom, this would be 270 degrees, or 1.5 ways to 2. So I went, 90 degrees is pi over 2. Pi is 2 pi over 2. So this guy here, we would say 1 1/2 pi, because it's halfway between 1 and 2, but we don't really write it as 1 1/2. Do you know the improper fraction for 1 1/2? 3 over 2, yeah. So we just say that's 3 pi over 2. And then 1 more half on the bottom there gets me to 2 pi. So our first famous angle family is that pi over 2 angle family. It's like your 90 degrees. So the pi over 2 angle family gives us our 90-degree values. Okay, now we're going to cut those halves in half. What happens when you cut a half in half? What do you get? A quarter, yeah. So our next family of angles is going to be pi over 4. Oh, no, wait, it's green. Sorry, wrong color. Ah. So I'm going to do this in green. Ooh, I don't want to do that. I'm just going to grab my eraser here. Sorry, I wanted it to be green. All right, so my next family is going to be green. And these are going to be our pi over 4s. Because when you cut a half in half, you get a fourth. So if I go halfway to pi over 2, I'm taking half of the half. 45 degrees is just pi over 4. That's a little hard to see, isn't it, that color? Can you guys see that okay? Maybe if I turn off that other light. Okay, remember, if you don't understand it, please don't write it down. Is that a little better? Okay, so that pi over 4 is 45 degrees because I went halfway to pi over 2. Half of half is a fourth. Okay, now I'm going to count off. So this is, like I said, you could look at it as memorizing, or you could just look at it as counting. So what I have here, this is 1 pi over 4. This guy right here, that's 2 pi over 4. This is 2 pi over 4 because 2/4 is the same as a half. So I have 1 pi over 4, 2 pi over 4. Anybody care to guess what that guy's going to be? 3 pi over 4. Nice guess. So we're just counting. This guy here is going to be 3 pi over 4. So again, we're counting. I got 1 pi over 4, 2 pi over 4, 3 pi over 4. This guy here, 4 pi over 4. Yeah, because 4 over 4 is just 1. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Anybody care to guess what this guy is? 5 pi over 4. Thanks for playing along with me. Oops. So that is, oops, sorry, not to make you seasick there. We got 5 pi over 4. All right, let's count again. Counting. We got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, because 6/4 is 3 halves. So 6 pi over 4, what is this guy? Yeah, nice job. We are looking at 7 pi over 4. Okay, wait, it gets better. This guy here, 8 pi over 4, because 8 over 4 is 2. So you could look at it as memorizing, or you could just look at it as counting. Your pick. So yeah, our pi over 4 family equates to our 45-degree family from a couple days ago. Okay. I really have one left, but I used 2 colors to indicate it. We have our 30-degree family, but your 30 degrees is going to hit your 60. So I'm just going to count 1 time the whole way around and take care of that red and blue line that you see. And this guy here is going to be our pi over 6. And you might be asking, like, Mrs. Lucas, why is it pi over 6? Good question. We can answer that real quick. It's pi over 6 because I'm taking my top sliver here. That's 1 pi over 6. 2 pi over 6. 3 pi over 6. I end up dividing that piece of pie into 6 pieces. 1, 2, 1, 2, 3, 4, 5, 6. You see 8. That's not good. Let me clean that up then. Undo, undo. Are you going to undo this? What am I going to do here? Yeah, good. That's probably what happened then. I didn't color very nicely, did I? Oh, I see what I did. Yeah, you're right. I just didn't do a good job coloring. I went too fast. Okay, well, let me show you what this looks like. I picked red. My pen. Okay. So this guy here, what I'm trying to tell you, that is 1 pi over 6. It's also not really drawn to scale very well that I'm looking at it, so my pieces do look bigger. We could write this next guy, since we're counting, as 2 pi over 6, right? But big kids aren't going to write 2 pi over 6, let's be honest. Why aren't they going to write 2 pi over 6? It's not reduced, yeah. So instead, you know, that would be 2 pi over 6, but as I indicated, the big kids don't write it like that. They're going to write it as 2 pi over 6 is actually pi over 3, because 2/6 is 1/3. So this guy here is 1 pi over 6. This guy here is 2 pi over 6. This guy here, we could say it's 3 pi over 6, because 3/6 is a half. So 1 pi over 6, 2 pi over 6, 3 pi over 6. Yeah, this would be 4 pi over 6, but would we write 4/6? No. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is 2 pi over 3. So that was 4 pi over 6. 5 pi over 6 isn't going to reduce. And then 6 pi over 6 is just pi. So just showing you again, I got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6 is pi. What comes after 6 pi over 6? 7 pi over 6, yeah. We're almost done, guys. You're doing a great job. 7 pi over 6. And I'm just counting. Again, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. This guy here, 8 pi over 6. But we don't write 8 pi over 6 because it's not reduced. Yeah, 4/3 pi or 4. Ah, wrong color. Boo. So we got 4 pi over 3. That was 8 pi over 6. 9 pi over 6. 10 pi over 6. We don't write it like that either. Yeah, 5/3 pi or 5 pi over 3. 10 pi over 6. And then we have 11 pi over 6. And then 12 pi over 6 is 2 pi. So pi over 6 gives us our 30 degrees and our 60 degrees. But better yet, I don't know if you noticed it or not, but anytime I had a pi over 3, that's really where I hit the 60-degree lines. So you could look at this as 3 different angle families or 4 different angle families, depending on if you look at the 30s and the 60s as the same or the 60s as pi over 3s. If you're like, why are the pi over 3s 60? I could point your eyeballs at that in a slightly different way. Do you see how everything close to the y-axis there had that pi over 3 on the bottom? That's these lines right here. Well, that's why I separated those as a different angle family. Questions about that? Okay, so now we're going to use this chart to actually draw angles on our very first diagram that we're not going to that with that just yet. Ooh. Step back a little. So I wanted you to take just a second. We're on example 1. And I wanted you to practice. See if you could do it without peeking. I wanted you to practice just for a minute. Just telling me what quadrant an angle is in. So see if you can do it from memory. If you have to look back, honestly, you guys just learned the circle 2 seconds ago. I wanted you to just take a quiet moment. Multiple choice. Quadrants 1, 2, 3, or 4. So picking up where we left off, you guys ready to check? This guy's quadrant 1.
2.
Why is that yellow? Did you get it right? Quadrant 1? Sweet. This guy was quadrant 1 if you got it right. 2 pi over 3 is quadrant 2. Pi over 4, that's your 45-degree angle, that's quadrant 1. 4 pi over 3 was quadrant 3. 7 pi over 6 is just past 6 pi over 6, so that's quadrant 3. 271 degrees is just past 270. Yeah, good job. 4. Okay, 2 radians. Quadrant 2, so you're taking your radius and you're wrapping it around twice. Pops you into quadrant 2. 5 radians is just before 6 radians, right? 4. So if you're wondering where that was in today's lesson,